The hallmarks of aging. What is aging? You can grow old without becoming aged, and you can be young but show signs of aging. So what really is aging? It's an accumulation of damage over a lifetime. Some collect more damage than others and thus age faster. This damage, or reaction to damage, comes in different forms. These forms can be called hallmarks. There are 3 criteria for something to be considered a hallmark of aging. Does it manifest during normal aging? Does experimentally increasing the hallmark accelerate aging? And does experimentally amending the hallmark slow aging? There are 9 hallmarks of aging. The hallmarks fit into 3 categories. Primary hallmarks are causes of damage. Antagonistic hallmarks are responses to damage. And integrative hallmarks are consequences of damage. Proteins have a complex structure that needs to remain stable for the protein to be functional. Loss of proteostasis means that proteins have an incorrect structure and the right amount of proteins aren't made. The incorrect proteins either prevent proper functioning in cells or are toxic to the body. Genes give instructions that tell your cells how to work and how to grow. The epigenome turns genes on and off. So if the epigenome is altered, genes can be left on when they aren't needed or stay off when they are needed. So the instructions to the cell are faulty, meaning the cell doesn't behave properly. Genes are made up of DNA. The DNA can get damaged, altering its information. Then the genes can no longer give the right instructions to the cells of the body. This leads to the cells being unable to produce functional proteins and thus are unable to operate properly. Telomeres act as a shield, protecting parts of your DNA from damage. As they shorten, they are less able to protect the DNA. Damage then builds up in DNA, altering the instructions it gives to the cells. Most cells die and destroy themselves. However, sometimes they stop functioning and become dormant. This is senescence. They can cause damage to tissues as they stay around but don't aid the body, impairing proper activity. The mitochondria provide energy to your cells. During aging, their efficiency decreases, meaning they are less able to provide the necessary amount of energy to your cells. This affects communication between cells and a cell's ability to work properly. The body is able to sense the concentration of sugars and fatty acids in the cells. When cells lose this ability, they can't properly store or release these nutrients when needed. This can cause blood sugar to be too high or too low, which can cause damage, for example, to nerves. Stem cells are cells that are able to differentiate into specialized cells in case of emergency. When they are exhausted, the number of stem cells decline, and they have a reduced ability to replicate. Without enough stem cells, organs and tissues are unable to recover from and repair damage to these crucial parts of the body. Cells communicate with each other using chemical messengers. When this communication becomes faulty, the different parts of the body can no longer function properly, and the immune system becomes weaker. All these tissues start to show inflammation, and this confuses the immune system, making the body more vulnerable to sickness and disease. Scientists around the world are working towards solving these issues. Here are some of the ways they're going about it. Genomic instability is the hardest to solve. The best method currently is prevention of damage to the DNA by avoiding carcinogens or aiding the genetic proofreading systems. Telomerase is an enzyme present in all of us that helps to repair your telomeres. Chemicals like TA65 can help increase the volume of telomerase and have been shown to reduce signs of aging in people. A compound called coenzyme Q10 is being investigated as it protects the mitochondria from damage, improves energy production, and promotes growth of new mitochondria. Rapamycin is a drug that helps inhibit the mTOR pathway. Rapamycin manages cell growth and promotes cell repair. Intermittent fasting and calorie restriction have also been shown to increase lifespan by 80% in mice. Both of these treatments also apply to epigenetic alteration and loss of proteostasis. A cure to aging is a way off. It is still a young field that is changing all the time. We may never be able to fully avoid old age, but we can try, both with science and in our everyday lives.